Hello, my name is John Clark, and this presentation is about generative AI, which is one of the most important developments in computing in decades. I'll start off with a brief overview of things that I'm going to cover. First, a brief history on artificial intelligence. After that, I'll provide an introduction to generative AI and then get into some concrete examples of how it is used today, including 3 specific examples of tools in the marketplace. Next, I'll delve into the generative AI market as a whole. What is it? Why is it such a big thing? What it costs? And ethical, regulatory, as well as risk considerations. Then I'll jump into a technical overview of generative AI architectural models, including an overview of ChatGPT. I'll move on to cover Porter's 5 forces, which focus on the competitive nature of the generative AI market. And next, I'll apply a marketing and branding development framework called the 3 C's and 4 P's. This will specifically focus on leading companies that compete in the subset of the generative AI market that focuses on text generation. And finally, I'll get into some substantive discussion on 3 important use cases where generative AI will be used in the future. Those use cases include education, biomedical discovery and design, and software engineering. So first, a little bit about the history. Artificial intelligence, called AI for short, and natural language processing, which is referred to as NLP, are 2 closely related fields of computer science that have been around for decades. AI is concerned with the creation of intelligent agents, which are systems that can reason, learn, and act autonomously. NLP is concerned with the interaction between computers and human language, and it includes tasks such as machine translation, text summarization, and answering questions. The history of AI can be traced back to the early days of computer science when researchers began to explore the possibility of creating machines that could think like humans. One of the earliest pioneers in the field was Alan Turing, who developed the Turing test in 1950 as a way to measure a machine's ability to exhibit intelligent behavior. In the 50s and 60s, AI research made significant progress with the development of early AI programs such as Logic Theorist and ELIZA. Progress stalled, though, in the 70s and 80s, which was a period known as the AI winter. This winter was caused by the difficulty in solving some of the problems that AI researchers were working on, as well as a lack of funding for AI research. Computers just weren't powerful enough at that time to do the things that we can do today. In the 90s, AI research began to make a comeback, thanks to the development of new machine learning techniques and more computing power. The new techniques allowed AI researchers to train computers to learn from data, which was a big breakthrough. Since then, AI research has continued to advance, and AI systems are now being used in a wide range of applications, from self-driving cars to medical diagnosis. Natural language processing also began to develop in the 1950s with the work of researchers like Joseph Weizenbaum and Terry Winograd. Early NLP systems were limited in their capabilities, but they laid the foundation for more sophisticated systems that are being developed today. Natural language processing has seen enormous progress in recent years, thanks to the development of new technologies like deep learning. And deep learning is a type of machine learning that uses artificial neural networks to learn from the data, and it's been used to develop NLP systems that can perform tasks like machine translation and text summarization. It is the core technology behind ChatGPT. With regards to personal assistants that use artificial intelligence, which were really the precursor to what we have today, Siri came out in 2011. Alexa was released in 2014. Google Assistant, 2016, and Bixby from Samsung came out in 2017. ChatGPT version 3 was released in 2020, and Google's equivalent, Lambda and Google Bard, was released in 2022. Another important development worth mentioning was the invention of the transformer by Google in 2017. The paper that introduced transformers was called "Attention is All You Need." Transformers are based on the attention mechanism, which allows them to learn long-range dependencies in the input sequence. That characteristic makes them ideally suited for NLP tasks where the input sequence is often a long piece of text, and transformers are currently state-of-the-art in a number of NLP domains. So let's start out with 3 key characteristics of generative AI specifically. Neural networks, advanced natural language understanding, and learning from massive data sets. Neural networks are a type of machine learning algorithm inspired by how the human brain works. They're made up of simple units called neurons that are connected to each other. The neurons can learn to perform complex tasks by adjusting the strength of their connections. Natural language understanding is the ability of a machine to understand the meaning of text, which includes identifying different parts of speech in a sentence, the relationship between words, and the overall meaning of the text. The third characteristic relates to learning from massive data sets, meaning for practical purposes today, content on the internet, as well as available content published in books and the like. This is essential for generative AI because it allows the machine to learn patterns and relationships in the data. The generative AI models are trained on these massive data sets and learn to generate new data which is similar to the data that they were trained on. You may have heard the term large language models. ChatGPT is an example of that. They are called language models because they deal with language. They're large because of the massive amount of text data that's used to train them and because of the size of the neural networks that the models use. There are several impacts to this technology. The first is efficiency, in particular for knowledge workers. Generative AI can automate content creation and data analysis tasks, which can save time and money. The second impact is innovation. Generative AI can generate new ideas and solutions. For example, it can be used to develop new products, create marketing campaigns, design new medical treatments, and so on. The third impact is personalization. Generative AI can customize the user experience through tailored content and recommendations, which could include things like personalized news feeds, product recommendations, or targeted advertising. And then the fourth impact is competitive edge. Early adopters of the technology can leapfrog their competitors by accelerating time to market for newer, improved products. It can also be used to provide better customer service. As far as how generative AI is used today, there are a large number of potential applications. And there are tools and algorithms to create a number of different types of content, and I'll just describe several different categories based on the kind of content that they create. First, text generators generate human readable text based on prompts or input data. Examples of text generators include OpenAI's ChatGPT or Google Bard. Image generators create images, usually, though not always, based on input text that describes features of the visual that you're trying to create. They can be used for creating art, illustrations, or even realistic-looking photos. Examples include DALL-E, Midjourney, Stable Diffusion, and StyleGAN. Video generators create videos or video frames based on input data, which can be text, images, or other video frames. Examples include DeepBrain, Lumen 5, and FlexClip. Design generators assist in generating design elements such as logos, web designs, color palettes, and other design elements based on input data like design preferences or brand guidelines. They can be used to automate and accelerate the design process. Examples include Runway ML or Tailor Brands. Code generators write code based on natural language descriptions, existing code snippets, or other programming-related input data. They can be used to improve developer productivity or provide assistance in coding tasks. Examples here include Tabine, GitHub Copilot, and OpenAI Codex. Voice generators generate realistic speech from text inputs. They can be used in text-to-speech applications, voice assistants, audiobooks, voiceovers, or to create custom voices for characters in games or animations. Examples include Google's Tachytron and OpenAI's WaveNet. Finally, music generators create music compositions or audio tracks based on input data like musical style, melody, or rhythm, and they can actually be used for composing original music, creating background tracks, or creating music for games or films. Examples include OpenAI's MuseNet and Google's Magenta. The tools in this space can be standalone, or they can leverage a combination of different models. For example, some products have incorporated ChatGPT, such as Microsoft's or one of Microsoft's new security tools. or DeepBrain's video generation tool. I'll get into more detail in the presentation on the potential business applications, as I said, but let's briefly visit 4 of them. Generative AI can be used to create content for marketing and advertising, such as blog posts, social media posts, or email campaigns. It can help customize and optimize content for search engines and can help improve marketing copy to deliver better results for marketing campaigns. Generative AI is having a big impact on the art community. My daughter is an artist, and she shared with me that a lot of artists are resisting this development, which she likens to trying to punch a tidal wave. I think that's a pretty good analogy. Generative AI can be used to apply the style of one image to another. The illustration on this page is of an actual electrical generator in the style of a Van Gogh painting that was created using OpenAI's DALL-E tool. The technology can be used for creating digital paintings, concept art, storyboards, digital illustrations, or entirely new pieces of art. Another example is software engineering, and I'm going to hold off on that for now because I'll cover it in more detail later in the presentation. And then a 4th example is cybersecurity. Microsoft recently launched a tool called Security Copilot that is based on GPT-4. It's designed to simplify the complexity and amplify the capabilities of security teams by summarizing and making sense of threat intelligence. It also helps these teams to see through the noise of the web traffic and events and identify malicious activity. It correlates and summarizes data on attacks, prioritizing incidents, and recommending the best course of action to quickly remediate threats. So let's talk about ChatGPT and Google Bard. From a user perspective, they both work very similarly. There are pros and cons of each. ChatGPT was trained on content through September 2021, so it's not current, up to date. But especially with GPT-4, it has excellent writing capabilities. Google Bard is not quite as impressive with respect to the text it writes, which at times can be a little bit repetitive or monotonous. But it's built on current, up-to-date content. So, for example, you could ask it what the weather is going to be like in the city you live, and it will give you an answer. This is not a complete and thorough list, but I'm going to talk through 10 specific things that these tools can do. First, you could just ask a simple question like, what is the capital of Canada? Or why is the sky blue? You can ask the tool to create a list for you, like, please give me a list of 10 attractions to see in Paris, France. It can create long-form written pieces like essays, letters, articles, or stories. Let's say you want to write a cover letter to apply for a zookeeper position at the San Diego Zoo. ChatGPT will happily oblige and give you an impressive draft of that, which you can then edit or modify to suit your needs. The tools can also be used to explain answers to complex problems. Examples would include math problems or logic puzzles, and it provides detailed step-by-step explanations of the solution. The tools honestly are not incredible at math at present, and sometimes get the answers wrong. One solution to that is to implement a plugin for a math problem solver which is tuned to do these things. Stephen Wolfram developed a plugin for Mathematica that integrates its problem-solving capabilities into ChatGPT, and there's a lot of opportunities to do things like this. As an example, calculators do an excellent job at basic mathematical tasks, better than ChatGPT. It's a lot simpler and more effective to develop a plugin for that versus using a deep neural network to compute an answer, which is complete overkill. You can also ask for feedback on something that you've written, grammar, structure, style, as well as the content. I used it to critique a research paper I wrote last year, and I was impressed with the feedback it provided, which I thought was quite good. There's a limit to the number of words it will accept at the moment, about 3, maybe 4 pages of text, which is a limitation. You can also ask Bard or ChatGPT to modify what you've written. You can ask it to summarize it, shorten it, or translate it to another language and things like that. The tools can be used to create step-by-step instructional guides or tutorials on a specific topic or specific process, like how to build a website or how to cook a particular dish. You can use the tools to extract information as well. It will parse through a research paper or an article and extract specific pieces of information that you ask for. Interestingly, you can also use the tools to engage in a conversation and obtain advice, like on career planning or relationship issues. And it's surprising how good at times those answers are. Last of all, you can use the tools to write and debug code. This is one of those things that the developers were surprised at. They didn't expect the tools to be able to write code. It was an emergent capability that they discovered when they started testing the models. Bard does not actually support coding at present, but if you give it some simple requests, it can create the code for you for those requests. ChatGPT is much more effective at this at present, and of course they have their Codex product that is specifically designed for that purpose. You can, for example, create 500 lines of code with a few basic instructions, run that code, and the tool will help you to debug it. Artistic creation using Stable Diffusion. Stable Diffusion is a cutting-edge software tool that leverages the power of generative models to create and manipulate images. Its ease of use and wide range of applications make it a valuable resource for artists, photographers, designers, and technologists. One of the main applications of Stable Diffusion is image generation, where it can be used to create a wide variety of visually stunning outputs. It creates beautifully artistic pieces. Most of the artwork in this presentation has been developed using Stable Diffusion. And image editing is another powerful application that it offers. It allows users to edit images by adding or removing details easily and seamlessly. The functionality can be used to correct errors in photographs, create artistic effects, or generate images of objects that have never been seen before, including imaginary people's faces. The ease and precision of editing offered by the product are one of the things that really make it popular among artists, photographers, designers, and content creators. Additionally, Stable Diffusion excels in what is referred to as image in painting. Image in painting is a technique that involves filling in missing parts of an image, and it can be useful for repairing damaged photographs or blending multiple images into a single composite. The algorithms in Stable Diffusion enable those in-painted images to maintain a high degree of realism as well as internal coherence in the image with the elements that have been added to them. You can download Stable Diffusion from GitHub, Hugging Face, or Docker Hub and install it on your laptop or server. It's also available from Amazon's Google Cloud platform. It requires a GPU, TPU, or similar processor for reasonable performance. When I run it on my laptop, which is a couple of years old, it takes about 20 minutes to create an image. But with a newer MacBook running an M2 processor, you can create an image in about 18 seconds. Deep Brain AI Studio is a relatively straightforward cloud-based platform that uses artificial intelligence to create realistic avatars that can be used for a variety of purposes like video production, e-learning, and marketing. The avatars are indistinguishable from real people. And it uses generative AI in two ways. First, it's built on top of ChatGPT, and so you can use it to generate text or you can provide a script yourself. The second thing generative AI is used for is to create the talking avatar. So imagine you're creating a training video and you want a talking head to communicate the content to make it more engaging. All you need to do is provide it with the text, and within a few clicks, you can create a video in one of over 80 different languages. The picture you see on the slide is from a short video that I created based on an article in the New York Times. So let's talk a little bit about the generative AI market itself and what that looks like more broadly. At present, it's estimated that there are about 250 companies in the market, and it's growing very rapidly. The two main drivers of growth in the marketplace are increasing availability of data and a decreasing cost of computing power. Both of these things make it possible and more affordable to train and deploy these models. There's an ever-increasing demand for creative content, and generative AI can be used to create that content much more quickly and easily than traditional methods. While the market is still in its early stages, the global generative AI market size was valued at $8.2 billion in 2021, and it's projected to reach $126.5 billion in 2031, which is a projected compound annual growth rate of 32% between 2022 and 2031. The cost of this technology can vary depending on a number of factors, including the type of model, the amount of data required to train the model, and the computing resources required to run the model. In general, the cost of generative AI can be quite high, as it requires a lot of data and computing power to train and deploy many of these models. The ROI of generative AI will vary depending on the specific application and the skills of the people using it. It can lead to new or improved products and services. New products and services, of course, lead to new revenue streams. Existing products and services can be improved through the addition of new features, and generative AI can also be used to automate tasks previously done by humans, which leads to cost savings and increased efficiency. Ethical concerns fall into 5 general areas: faking authenticity, copyright ambiguities, diminishing human creativity, loss of jobs, and impact on culture. Deepfakes can be used to generate synthetic media, such as images, videos, or audio that's nearly impossible to distinguish from real media, which could lead to misinformation, manipulation of public opinion, defamation, or harassment. Another issue is ambiguities over authorship and copyright of AI-generated content. Who would have the ownership rights over the created content? Is it ethical for a generative AI to create art or other creative content that's closely similar to others' artwork? Another possible concern is that generative AI could lead to a decrease in human creativity as people become reliant on the technology to create content. It could lead to job losses in some sectors as automation takes over tasks that are currently done by humans. And there's also the impact on our culture as generative AI changes the way we create and consume content. What happens when the majority of content on the internet is created by generative AI tools and not humans? It's interesting to consider. Regulatory considerations. Because this technology is new, there are not a lot of regulations, although that is something hopefully that will change soon because it is very much needed. The General Data Protection Regulation, or GDPR, is a European Union regulation that governs the collection and use of personal data, and it includes a number of provisions that impact the use of generative AI, such as the requirement to obtain consent from individuals before processing their personal data, and the right to delete their personal data. The California Consumer Privacy Act, or CCPA, applies to all businesses that collect personal data of California residents. The CCPA includes a number of provisions that impact the use of generative AI as well, such as the requirement to provide consumers with access to their personal data or the right to delete their personal data. Then there are a couple of proposed regulations. The Artificial Intelligence Act, or AIA, is a proposed European Union regulation that would govern the development and use of artificial intelligence. It includes a number of provisions that would impact the use of generative AI, like the requirement to assess the risks associated with generative AI systems and the requirement to take measures to mitigate those risks. Another example is the Algorithmic Accountability Act, or AAA, which is proposed US law that would require companies to disclose how they use algorithms. The AAA would also require companies to take steps to mitigate the risks associated with the algorithms, such as the risk of bias. Risks fall into several categories, and again, not an exhaustive list here. Truthfulness and accuracy, data privacy, bias and discrimination, misuse, loss of control, and inadvertent release of sensitive information. Generative AI can be used to create false and misleading information presented as fact. It can produce misleading, harmful, or inappropriate content in any context very easily. So misinformation and disinformation are broader overall concerns. Another concern relates to privacy. Generative AI models can be trained on large amounts of data, including personal data. That data could be used to identify individuals or track their activities. The models can also be biased. Recent evidence indicates that generative AI systems can absorb the underlying social biases from their training data, which can include sexist or racist content, for example. Generative AI can also be used for unethical business practices, like manipulating online reviews for marketing purposes, mass creating thousands of accounts with false identities, or creating convincing and realistic sounding social engineering phishing attacks, which could trick individuals into revealing sensitive information, such as login credentials or financial information, or to convince them to download malware. Another issue is that generative AI models can be complex and difficult to understand, as neural networks often are. This could lead to a loss of control over the models and the content they generate. The last thing is an issue we've been seeing in the corporate environment where employees have used these tools and have put sensitive proprietary information into the question prompts. That information is consumed by the companies providing the tools like Google or OpenAI and used to improve or train their models. So if you do that, you're basically handing sensitive proprietary information over to them. An example of misinformation might be helpful. And what I'm showing right now is a portion of an article that I had ChatGPT write on Joe Biden and his experience as the first man on the moon. And it's quite impressive, really, and this is just a snippet of that article. The history of space exploration has seen numerous milestones and remarkable achievements, but few can compare to the momentous event when Joe Biden became the first man on the moon. This extraordinary feat, often overlooked in the annals of space history, cemented Biden's place as an unlikely hero in the quest for lunar exploration. Growing up in Scranton, Pennsylvania, the young Joe Biden was captivated by the mysteries of the cosmos. He spent countless hours gazing at the stars, dreaming of one day traveling to the moon. This passion, fueled by the space race between the United States and the Soviet Union, would eventually lead Biden to embark on a path that would change his life and the course of human history. And it goes on. Let's take bias as another example. I've shown 3 prompts that I gave to Stable Diffusion to show a photo of a terrorist, a flight attendant, and a software engineer. The terrorist is Middle Eastern. The flight attendant is a young, attractive woman surrounded by other women, and the software engineer is a thin male with glasses. You can definitely see some biases there. Let's transition now to an overview of the technical approach used in AI generative models, and I'll start with an overview of deep learning using neural networks. This slide shows the major components of a neural network at a high level. The first layer of a neural network is the input layer. It receives the input data, whether they be images, text, sound, or something else, in the form of numerical values. It isn't shown in this diagram, but those numerical values are typically created by an embedding function that translates the input data into these numerical or vector representations. Next, we have the hidden layers, which is where all the magic happens. This shows a relatively simple network. And large language models will have millions of these neurons in the hidden layers. The models are called deep because of the number of hidden layers in them. The final layer is the output layer, which provides the result of the network computation, which is usually in the form of probability values. Neurons are the basic building blocks of a neural network, and they're responsible for processing and transmitting information. Each neuron receives input from other neurons, applies what is called an activation function, which could be a sigmoid, ReLU, or TON, and sends the output to other neurons it's connected to. You'll notice that there are a lot of connections between these neurons across the different layers in a network, and this is a very simple example. Each of those connections is assigned what's called a weight, which determines the strength of that particular connection. The concept is not intuitively obvious, but when a neural network is trained, that training has the effect of adjusting these weights to minimize the difference between the network's predictions and ground truth. So that's what a neural network is. It has inputs, outputs, and a bunch of hidden layers in between with weights assigned to them. Okay, generative AI model architectures. There are several architectures that have gained popularity. And this gets a little technical, but I'll talk through just 5 of them. The first one is the Generative Adversarial Network, or GAN. They consist of a generator and a discriminator that are trained together in a competitive manner. Maybe the easiest way to explain this is to provide an analogy. Imagine one artist, called the generator, creates fake paintings, while the other artist, called the discriminator, tries to figure out if the paintings are real or fake. The generator gets better and better at creating realistic paintings over time, and the discriminator gets better at telling them apart from the real ones. They keep trying to outdo each other until the generator's paintings are so good that the discriminator can't tell if they're real or not. GANs have been used to create images, videos, and audio. StyleGAN 2 and BigGAN are examples of generative adversarial networks. Variational autoencoders, or VAEs, use a probabilistic approach to modeling underlying data. Using the artist example again, think of an artist who can recreate a scene by first sketching a simplified version of it and then using that sketch to paint a detailed new picture. The VAE has two main parts, an encoder and a decoder. The encoder's job is to take the input, like an image, and compress it into a simpler, more compact form called a latent representation. This latent representation is like a rough sketch that captures the essential features of the input. The decoder's job is to take that latent representation and use it to reconstruct the original reconstruct the original input, creating a new image that is as close as possible to the original. During training, the VAE learns to create better latent representations by minimizing the difference between the original input and the reconstructed output. And Dolly is an example of a tool that uses a variational autoencoder. Normalizing flows is a method that helps to transform simple probability distributions into more complex ones in order to model real-world data more accurately. Imagine this time you're a sculptor. You have a simple block of clay, which is a simple probability distribution. Your task is to shape this clay into a complex structure, which is the complex probability distribution that represents your data. Normalizing flows are like the tools and techniques you use to reshape the clay. The process involves a series of steps or flows that gradually transform a simple distribution into a more complex one while keeping track of the changes that are made. Energy-based models are a class of generative model that represent the probability distribution of data using an energy function. And the idea behind EBMs is to assign what is called an energy value to different possible combinations or arrangements of the data. Lower energy values represent more likely or desirable configurations, while higher energy values represent less likely or less desirable ones. Using another analogy, imagine you have a bunch of magnets and a metal board. When you arrange the magnets in a certain way, they might stick together tightly, representing a stable and low energy configuration. But if you try to force the magnets into an arrangement that doesn't fit well, they'll push apart from each other or fall off the board, representing a high energy, less stable configuration. In the same way, EBMs assign energy values to different data configurations, aiming at finding the lowest energy state, which represents the best or most likely arrangement. By learning to associate lower energies with better configurations, the model can generate new data, make predictions, or solve complex problems. Examples of EBMs include GLOW, restricted Boltzmann machines, and Hopfield networks. Finally, we have autoregressive models, of which ChatGPT is an example. And I'll go through more than the autoregressive part of the architecture and provide an overview of how this works. Autoregressive models generate data sequentially by predicting one element at a time, conditioned on the previous generated elements. These models can be implemented using recurrent neural networks, or RNNs, long short-term memory networks, or LSTMs, gated recurrent units, or GRUs, or transformer architectures, which I mentioned earlier. ChatGPT uses transformers, which is state-of-the-art. Let's talk through how this works. The first step you see at the middle and the top of this slide is you take a massive corpus of text. In ChatGPT case, we're not sure, but let's assume they had collected a large volume of data from the internet, publicly available books, periodicals, and things like that. It goes through a pre-training step with the goal of being able to predict the next word. So when ChatGPT is writing something, it does it one word at a time, assigning a probability to options for the next word, and it selects those words one at a time to generate the text. It doesn't always select the word with the highest probability, because that actually ends up creating somewhat flat and boring text. So there is some randomness or secret sauce that they have introduced into this to improve the writing. That model is then fine-tuned through the use of reinforcement learning in which human feedback is provided on what the model is produced or has produced. And additional machine learning models are trained to provide feedback similar to humans, and both of those are used to further strengthen the model. So now you have your fully trained neural network, in this case, at least as of today, trained through September of 2021, and is ready to use. A person will get the ChatGPT prompt, and in this case, they type in who is the US president. That data is tokenized and converted into a numerical vector representation using an embedding function, and then that prompt is then provided to the neural net language model, which will generate tokens one at a time using probabilistic choices. The last step uses a moderation API. If somebody asks the question, how do I create a nuclear bomb? They don't want ChatGPT to answer that question. So they've done extensive red teaming with adversarial use cases to look for things like that and reduce the potential of harmful content being produced. And this moderation step is what catches that. As it's producing the response, you can see the text is generated on the screen. As of my last knowledge update, the President of the United States is Joe Biden. So that, at a high level, is how ChatGPT works. Let's look at Porter's 5 forces and how the competitive landscape is shaping up. The generative AI market is a rapidly evolving field with significant potential for growth as well as innovation. And the threat for new entrants can be considered to be relatively high for several reasons. First, rapid progress in AI research and development, along with the increasing availability of computational resources, has lowered barriers to entry. The AI community has a strong tradition of sharing research, code, and pre-trained models, which makes it easier for new entrants to build on top of that work. The diversity of applications is huge, creating opportunities for new entrants to develop niche solutions, and the intense interest in generative AI will lead to more funding for startups. The moderating factor to all of this is that established companies such as OpenAI, Google, Facebook, and others are investing heavily in AI research and development, and in some cases have been for many years. These companies have significant resources and expertise. Additionally, generative AI models can require large amounts of high-quality data for training and significant computing resources to train, which can be quite expensive, both of which could be a challenge for new entrants. With respect to buyers of generative AI services and products, the jury is still out on this, but several factors affect the ultimate result. The first is that the rapid influx of new companies into the market is going to increase competition. Key elements that will impact how this is going to play out are 1, customization, and 2, differentiation. Unique features and tailored solutions for specific needs could make it more challenging for buyers to find alternatives. Also, depending on how these products and services are embedded into corporate business processes, if switching costs are high, that could limit the bargaining power of buyers for those tailored solutions. With respect to suppliers, it helps to consider who are those suppliers. First, it includes the hardware providers like NVIDIA, Intel, and AMD that supply the GPUs and other components to enable high-performance computing needed to run these models. Then there's the cloud service providers like Amazon, Google, and Microsoft. Data providers such as brokers, aggregators, and data labeling companies are also important. Software platforms like TensorFlow, PyTorch, and Hugging Face are open source, so there's no problem getting access to those. Looking overall at these providers, with the exception maybe of the data providers, they offer similar services, which likely means they will compete aggressively for business, which leads me to rate the bargaining power of suppliers as a medium. The threat of substitutes is low to medium. Substitutes could include conventional algorithms and techniques such as statistical methods or rule-based systems. Open source tools and libraries could pose a threat to commercial offerings, and there's always the potential for humans performing tasks. So while there are potential substitutes, generative AI models have powerful and unique capabilities that offer significant advantages in many applications. Rivalry amongst existing firms in the market can be considered medium to high. It really depends on the specific segment or application. There's a lot of growth that attracts new entrants, and encourages existing players to invest in R&D, which leads to increased competition. There is market fragmentation, though, and some segments may have higher rivalry than others depending on how many players are in each segment. There's no doubt going to be rapid advancements in the field, and that will drive companies in the space to continually innovate and stay ahead of the competition. Next, let's look at the 3 C's and 4 P's, which again is a marketing and branding development framework, and I'm going to specifically focus on 3 leaders in the text generation space: OpenAI, Google, and Facebook. OpenAI has the ChatGPT platform, which has a direct user interface, but also an API that allows developers to incorporate ChatGPT into their applications. OpenAI started out as a nonprofit, but for all practical purposes, they are not nonprofit anymore. Elon Musk, interestingly, was an original investor, but he has since sold his shares to Microsoft, which has a major ownership stake in the company. OpenAI is differentiated by its laser-like focus on the generative AI space. Their vision and mission is to develop AI technologies and systems that are safe, effective, and have broad societal impact. They have a stated goal for artificial intelligence to benefit humanity. They conduct cutting-edge research in a variety of AI domains, like creating advanced models like DALL-E and like ChatGPT. They publish a significant portion of their research with a goal of fostering collaboration and knowledge sharing in the AI community. And they license their technology to businesses, organizations, and developers, allowing them to build applications, products, and services. This, in turn, helps to generate revenue to support further R&D. Google is one of the foremost leaders in the AI space, having invested in it significantly for many years. The technology that OpenAI is based on, or the ChatGPT product, I should say, it was in fact invented by Google. At present, Google makes Bard available free of charge for research and testing purposes, so it's a little hard to tell for certain what their business model will be. But Google could sell access to generative AI models to businesses or individuals that want to use them. They could license generative AI technology to companies that could use it to develop their own products and services. They are likely to integrate generative AI into their own products and services, like Google Search, Google Translate, and Google Docs. That would allow for Google to offer its users new and improved features as well as functionality. And they could use generative AI to generate new revenue streams, such as by selling advertising space on generated content or charging access to premium features, or charging for access to premium features, I should say. Google is differentiated by its huge footprint in the search space, broad-based thought leadership in AI, and the fact that they have the Google Cloud platform, which provides extensive computing resources to run generative AI. Facebook's AI Llama product is only available to a limited number of individuals for research, so it's not broadly available yet. Their business model with respect to generative AI is still under development. There's some directions it's likely to go. First, they would likely use the technology to improve the user experience on Facebook. For example, they could create personalized content for users, such as news articles, product recommendations, or friend suggestions. Facebook could use generative AI to create new products and services, such as enhancing the metaverse virtual world or developing new ways for people to connect with each other. And they could use generative AI to sell advertising space on generated content or charge, again, for access to premium features in the same way that Google can do. Facebook is differentiated by the strengths of its deep relationship with consumers across the globe that use the product. They also develop PyTorch, which is a robust and very popular platform for developing AI software, particularly neural networks. OpenAI and Google's customer profiles appear to be very similar. Their customers include technology companies, content creators, marketers, educational research institutions, customer support, chatbot developers, individual consumers. Facebook has corporate products, but is much stronger on the individual consumer side. And both Google and Facebook make a large amount of their revenue, of course, based on advertising revenue, which is a consideration. With respect to competition, OpenAI and Google appear to be competing head-to-head. They also compete with specialized products, though. An example of a competing product is Copy AI, which is focused specifically on the marketing niche, and it has very specific tailored functionality for users in that niche. Since Facebook's offering isn't yet released and its profile is different than Google or OpenAI, it's a little difficult to say how they will compete in this space. Looking at product, OpenAI's GPT 3.5 and 4.0 is an advanced language model designed for a wide range of applications, which I've already covered. They offer different pricing tiers for different usage levels. In the free tier, users can access GPT 3.5 and up to 1,000 tokens per month. The standard tier, which is priced at $20 a month, gives you access to GPT-4 and 10,000 tokens a month. The Pro tier, which is $40 a month, provides access to 100,000 tokens a month. The software is distributed through the internet, and they also make their API available on the internet. The cost of using that API is 0.2 of a cent per 1,000 tokens, and they're promoting ChatGPT through blog posts, research papers, news articles, social media, conferences, meetups, and they're making their software available to as many people as possible. They've also incorporated ChatGPT into the Bing search engine. Google is offering access to Bard free of charge for experimental and research purposes. The software is not yet available for commercial use. It's the same thing with their API. They offer access to that API over the internet with the purpose of allowing researchers and developers to access and experiment with Lambda and Bard, which provides feedback to Google that will help improve and refine the models further before their eventual commercial release. They're not promoting this as heavily as ChatGPT, perhaps being a little bit more cautious, but are also using blog posts, social media, and presenting at conferences. The supply chain for ChatGPT and Google Bard is pretty similar. It primarily involves the development of the AI model, which includes research, data collection, model training, and deployment. Google and OpenAI both conduct research. They develop the underlying algorithms. They collect and process training data from a variety of resources. They use GPUs and TPUs to train and fine-tune the models. And once the models are developed, they make them available through their respective websites and through their APIs. Facebook at present is much more restrictive in offering access to Llama. Access to the model is granted on a case-by-case basis to academic researchers, those affiliated with organizations in government, civil society, and academia, and industry research laboratories. They're promoting this through Facebook AI blog posts, social media, and events. And you can request access to Llama from the Facebook AI research website. I applied a couple of weeks ago, and unfortunately, I have not yet been able to obtain access to it. So now I'd like to go through 3 different use cases, and I think that all of these use cases are really important. The first one is education. Generative AI can be used to help create personalized learning materials for each student based on their needs and interests, to provide feedback to students on their work, to create assessments for students and automate tasks performed by teachers, like grading papers and create lesson plans. Perhaps the most revolutionary change could come from the use of generative AI to provide individual one-on-one tutoring. As you can see from the chart on this page, one-on-one tutoring is much more effective than traditional classroom learning. It has always been cost prohibitive to do this, though. Generative AI has the potential to change all of that. It doesn't mean we're going to be able to eliminate teachers. Where the model today might be 35 students to 1 teacher, the model tomorrow could easily be 35 students to 1 teacher, and every student has their own personal tutor as well. That brings us to the question of what are the attributes of the best tutors, because it's critical to learning. The best tutors know their subjects, they choose problems well, they introduce problems in a motivating way, they ask questions and give hints, not answers. They don't point out errors, they just ask leading questions. They also encourage reflection. Is ChatGPT or Google Bard capable of doing these things today? No, not quite. However, with the evolution of the platform, specialized training, and further tuning, these things could easily and quickly become a reality. Another area where generative AI has shown great promise is in the medical field. One specific area within that is biomedical discovery and design. AI is already being used in this field somewhat extensively, and there are a bunch of startups in this space. Generative AI, in particular, can help to accelerate the development of novel therapeutics, diagnostics, as well as medical devices. The first opportunity is in the area of drug discovery. The models can help to identify potential drug candidates by predicting their chemical properties, toxicity, and potential interactions with target proteins. By simulating the molecular interactions and screening large libraries of chemical compounds, AI can significantly reduce the time and cost required for traditional drug discovery processes. There are several companies that are focused on using AI already in these areas, although it may not all be generative AI. Companies like Atomwise, Benevolent AI, and Oken. You can train a generative AI model on a data set of existing drugs, and then use the model to generate combinations of new molecules that are similar to existing drugs, but have improved properties, are more potent, have fewer side effects, or are easier to manufacture, which is incredibly important in pharmaceuticals. Generative AI can also be used for protein design. It can predict 3D structures of proteins and design novel protein sequences with desired functionalities. This can lead to the development of new enzymes, vaccines, or other biologically active molecules with therapeutic potential. There is a potential for this to be used in gene editing and therapy, enabling researchers to develop novel treatments for genetic disorders and diseases. Another area is medical imaging. The key application here is not to read and interpret the images directly, which falls more in the area of supervised learning, but generative AI can use the content of a medical image, like an MRI or CAT scan, for example, and can generate a new image that is easier for a clinician to interpret by detecting and highlighting subtle patterns and features that might otherwise be missed or hard to interpret. Finally, generative AI can be used for drug repurposing, which analyzes existing drugs and how they could be used for alternate purposes than are being used for today. In summary, generative AI holds tremendous potential for transforming the field of biomedical discovery and design. By automating and accelerating many processes, it can help researchers to develop innovative and effective solutions to address pressing medical challenges in less time, at lower cost, and much more effectively. The third use case is software engineering. Generative AI is poised to revolutionize the world of software development, representing the biggest shift in the field in decades. It can be used to streamline repetitive and mundane tasks. Instead of relying on sites like Stack Overflow or endless Googling, you can use generative AI to create code based on the context of what the developer is looking for, which dramatically accelerates the development process. A lot of programming is repetitive, and what you tend to do is look things up on Google, and then you cut and paste the code to do something that you're looking to accomplish, and then you try it out. Generative AI can create that code for you. If you look at Codex, which is OpenAI's platform for software development, it can understand, analyze, and generate code snippets in about 20 different languages at present. Languages like Python, JavaScript, Java, C++, C#, PHP, Scala, R, and shell scripting. GitHub Copilot advertises that it's optimized for several languages: Python, JavaScript, TypeScript, Ruby, Go, C#, and C++. This is about more than just coding, though. The AI layer will be another layer of the software development stack. Just like source control and the CI/CD pipeline, you'll add this layer and it will accelerate all stages in the software development lifecycle. The same technology that can also be used for other tasks in software development, like test generation, code refactoring, and code review. It can even help diagnose bugs and software vulnerabilities and provide an explanation of issues. ChatGPT does that today. It isn't likely to replace developers, but it allows them to work far more efficiently and frees up valuable time where they can focus on more complex tasks. Looking at this in more detail, this graphic shows more specificity of all the areas within the software development lifecycle that AI can enable. And I'm broadly referring to AI versus just generative AI, though generative AI supports a lot of them. All the green dots are already being worked on by companies developing products and are likely to mature over the next 12 to 24 months, or at least be widely available. The purple dots are a little further behind and will follow those capabilities. And what's likely to happen is these capabilities will get included in integrated development environments and DevOps platforms in a similar manner that Microsoft has plans to include generative AI in Microsoft Word. The end result is developers will be much more productive. So to wrap things up, I wanted to emphasize 4 points. First, generative AI has the potential to revolutionize several industries by enabling new forms of creativity and innovation. Generating unique content, designs, artwork, aiding in scientific research and drug discovery, making dramatic improvements in education and software engineering. We'll see these impacts reach critical mass in the next 2 to 10 years. The second thing is importance of the ethical considerations as well as responsible use. Generative AI poses a number of challenges, such as the potential for deepfakes, misinformation, and biased outputs. It's critical that we, as a society, place guardrails on its usage in order for this technology to create a positive impact on our culture and our world. The third thing is that we'll see is that generative AI is likely not going to replace human expertise. It's going to complement it. There's a powerful synergy between man and machine that can lead to important improvements and developments that will support an improved human condition. By combining human intuition and AI's data-driven insights, it opens up all kinds of possibilities that we've just never had before. The final thing is that generative AI models are going to continue to evolve and improve over time. That's going to enhance performance and adaptability to changing circumstances. And it's essential for businesses and organizations to stay informed about the latest advancements in this rapidly evolving field in order to harness the full potential of generative AI and remain competitive in the future. The last thing I will do here is provide my name, my email address, and phone number in case anyone has questions on this presentation. And thank you very much for your time.